these are the notes for Algebra 2, Section 8.4. This is Part 1 of 2 parts of 8.4. This part is looking at simplifying rational expressions. Now, a rational expression, of course, is an expression that has a variable on the bottom of a fraction. Now, a rational expression is simplified, and remember, simplifying is what we're trying to do. A rational expression is simplified if its numerator and denominator have no common factors. Right, now remember, a numerator goes up on top, right? Numerator on top, denominator on bottom. Writing too small. Numerator on top, denominator on bottom. We should all remember that, I hope. As long as the numerator and denominator have no common factors, then the rational expression is simplified. This is just like a fraction, right? We always have to reduce our fractions, and we have to reduce our rational expressions, because rational expressions are factors. Now, the way that we simplify them is actually exactly the same as the way we simplify fractions, right? We have a fraction a times c over b times c. We can cancel out c on both top and bottom, right? We divide out that common factor. We cancel out a common factor that's on top and bottom, leaving us with just a over b. And that's pretty much all there is to it. For instance, if I had, let's make it a little bit interesting here. If I had x plus 2 times x minus 1 over x minus 4 times x minus 1, right? Even though these are binomials and they don't look like a's and b's and c's, the same rule still applies. I have an x minus 1 on top and an x minus 1 on bottom. Those two guys will cancel each other out, leaving me with just x plus 2 over x plus 4. And this is the simplified form. Now you'll notice I still have x's on top and bottom. 2 and 4 you might think you could reduce. But since we're adding these things together on top and bottom, we cannot simplify them. Right? We are only allowed to reduce if there's multiplication going on. Multiplication is the only thing that works. We must be multiplying. And I'm even going to put that here. Must be multiplying. Right? If you are not multiplying, you cannot do this. You cannot cancel out a common factor. Alright, so that's the basic trick. That really is all there is to it. Now, of course, obviously there are going to be some more steps involved. Not every problem is going to give you a bunch of binomials that you can cancel out. But we can see it's not going to be too terribly difficult. For instance, example 1, we want to simplify x squared plus 7x plus 10 over x squared minus 4. Now, the first step that we want to do is to factor the numerator and the denominator. We want to factor both of these. Now, put a little line here. I want to factor x squared plus 7x plus 10. Now, of course, the quick and easy way to factor would be to start with my parentheses. I put my x's. Now, since I have a plus here at the end and a plus here in the middle, both of these have to be plus. The factors of 10 that add up to 7 are 5 and 2. So I have x plus 5 and x plus 2. Now on the bottom, you might get a little confused here at x squared minus 4, but keep in mind, this is x squared minus 0x minus 4. Alright, so we can treat it the same way. Alright, we can say, okay, well this is x and x. This is minus, so it has to be plus and minus. We have to add up to 0. So that's positive 2 and negative 2. Now, I want to rewrite this to make this look a little bit nicer before I divide out a common factor. So let's rewrite this, x plus 5 times x plus 2. I'll leave that the same. But on the bottom, here's what I'm going to do, just to make it a little bit more straightforward. X minus 2, x plus 2. I just swapped those guys around. This is before I divide out a common factor. Now, you don't have to do this step. This step, the moving around step, is optional. I like to do it because then it becomes much more obvious that these two guys are going away. And if those two guys are going away, I have x plus 5 over x minus 2. And that is my simplified form. So you see we factored and then we canceled stuff out. Again, fairly straightforward as long as we get the factoring together. Let's try another one here. This is example 2. Now, in this one you might notice we already have a bunch of binomials floating around. This is nice. They've done the factoring for us. So factoring was done for us. The factoring is already done. So that's nice. If the factoring is already done, we don't have to do it. Yay! Instead, we can just look at stuff that can cancel out. Now, of course, in order to cancel out, terms must be on both top and bottom. Here we have x minus 1 on top and x minus 1 on bottom. Those two guys will cancel out. When they cancel out, we're left with 2 on top and x plus 3 on bottom. And that's our answer. So fairly simple. Cancel out the two terms that are the same. Everything else sticks around. All right, one last example here. We're looking at example 3. And we want to go about this the same way we went about example 1. We want to factor top and bottom. So that's going to be our first step. We're going to factor. So here we go. Let's start by factoring the top. We start with our parentheses and our x's. This is negative, so we have to have plus and minus. Factors of negative 3 that add up to negative 2 would be 1 and negative 3. So that's our factors on top. You can see how doing this quicker version of factoring makes life a lot easier as we go through and do all this factoring. It makes solving the problem not quite so bad. Again, parentheses, x's. A minus sign here, the minus sign there, the minus sign here means plus and minus. Now, the factors of negative 6 that add up to negative 1 are negative 3 and positive 2. So that would be our next step. After that, we factored, so we want to cancel. And what we can cancel is right here. Negative 3, x minus 3, and x minus 3 cancel out. So, yay, those two go away. And our last step is to simplify. Usually, this step mostly just involves rewriting what we've got. If we can get rid of parentheses, we should do that too.